Welcome, leaders and innovators. Today, we are exploring the absolute bedrock of any successful AI strategy, your data. We will uncover how data type, quality, and representation dictate the success or failure of your generative AI investments. Let's get started. Welcome to our session on the profound impact of data on generative AI solutions. If there is one fundamental truth in AI, it is that your AI is only as good as the data it learns from. Generative AI models, such as Microsoft Copilot, rely entirely on data to recognize patterns and produce outputs. In this slide, we outline the absolute basics. What does this mean for you? It means that trustworthy AI does not happen by accident. It depends directly on the dual pillars of high-quality data and strong security practices. Why is this so crucial? Because if your underlying data is incomplete, heavily biased, or wildly inaccurate, the generative results will be inherently misleading. How do we solve this? By shifting our focus from the AI model itself to establishing rigorous data readiness before deployment. As a deep dive, business leaders must recognize that trust is not merely a technical issue, it is a core business imperative. Without reliable data, you cannot build trustworthy AI, and without trust, user adoption will fail. Let's explore how data shapes this reality. Let us direct our attention to the flowchart on your screen, which visualizes the core dependency between data and business outcomes. At the very top, we begin with the foundational node, enterprise data. Notice how it acts as the singular feeder into the generative AI model. This represents that the model is simply a processing engine. It has no inherent truth outside of what you feed it. The AI model then branches into two potential pathways based on the data's condition. If the data is clean and secure, it flows to the right, creating trustworthy AI that directly drives high business value. However, if the data is compromised, biased, or unsecured, it flows to the left, resulting in misleading outputs and severe compliance risks. As a trainer, I want you to remember this visual every time an AI project is proposed. You cannot achieve the green nodes on the right if you ignore the blue node at the top. Your data's integrity is the absolute ceiling for your AI's success and your ultimate return on investment. Moving to our second core concept, data type. What do we mean by data type? We are referring to the format in which your business information is stored and consumed. The basics divide data into two camps: structured data, which lives in neat rows and columns like SQL databases, and unstructured data, which includes your emails, Word documents, PDFs, and chat transcripts. Both are used in AI, but why is this distinction critical? Because AI tools, particularly Microsoft Copilot, often rely heavily on unstructured enterprise content to help employees in their daily tasks. How do you handle this? You must recognize that searching a rigid database is technologically different from comprehending a nuanced email thread. For our deep dive, realize that because Copilot depends on this unstructured data, your files must be exceptionally well organized and accessible. If your company SharePoint is a chaotic dumping ground of unlabeled files, the AI will struggle to parse the correct context. You must structure your unstructured data through proper file management to empower the AI engine. Take a look at this mind map illustrating the bifurcation of data types in AI. Starting from the left, our data splits into structured and unstructured paths. The structured data path leads to strict environments like databases, ERPs, and spreadsheets. Traditional machine learning thrives here. However, follow the bottom path for unstructured data. This leads to emails, chats, documents, and PDFs. Notice how these specific nodes funnel directly into the Copilot focus circle. This visually emphasizes a vital learning point. While structured data is important for numerical predictions, the vast majority of human-centric generative AI applications like drafting a proposal or summarizing a meeting rely almost exclusively on your unstructured data. If your organization wants to reap the benefits of generative AI, you must ensure that the unstructured nodes on this diagram are securely managed, properly permissioned, and highly organized. Our third slide addresses perhaps the most tangible metric: data quality. What is data quality? It is the measure of how accurate, current, and complete your information is. The basics are a tale as old as computing. AI systems need clean, validated data to generate meaningful results. Why is this so crucial for generative AI? Because generative models are incredibly confident. If you feed them inaccurate, outdated, or incomplete data, they will confidently generate highly unreliable and misleading outputs. How do we prevent this? By establishing aggressive data hygiene routines. You must actively archive obsolete documents so the AI doesn't read them. The deep dive here is the classic garbage in, garbage out paradigm, but magnified. Imagine your company updated its HR benefits policy in 2024, but the old 2018 PDFs are still sitting in an active SharePoint folder. The AI might retrieve the outdated 2018 policy and confidently give a new employee the wrong medical coverage information. Quality control is not optional, it is mandatory. This flowchart demonstrates the direct cascade from data quality to business output. We start at the top with raw enterprise data. Immediately, we hit a critical decision gate. Is data clean and current? If the answer is no, we follow the left path, pulling in inaccurate or outdated info. This feeds directly into an unreliable AI output. This is where companies lose trust in their AI investments. But if we invest in data hygiene and the answer is yes, we move down the right path to validated data. This clean data powers the AI to produce meaningful and actionable outputs. This diagram should make it perfectly perceivable that the AI model itself is constant. The only variable that changes the final outcome from unreliable to actionable is the quality gate in the center. Your data governance team controls that gate. Slide 4 tackles a nuanced but highly critical topic: representative datasets. What does this mean? A representative dataset is one that accurately reflects the full diversity of the users, scenarios, and languages your organization serves. The basics are simple. An AI model learns its entire worldview from the data you provide. If that data is narrow, the AI is narrow. Why must leaders care about this? Because if the data does not reflect your true diversity, the AI might produce heavily biased or completely irrelevant results. How do we solve this? By auditing our enterprise datasets to ensure all regions, demographics, and languages are included before deploying an AI agent globally. For our deep dive, recognize that representative data is the technical mechanism for achieving Microsoft's responsible AI principles, specifically fairness and inclusiveness. If a global bank only trains its AI on North American loan approvals, the AI will perform poorly and unfairly for European or Asian clients because it lacks representative context. Diversity in data is a core performance metric. Let's follow the logic of dataset representation using this left-to-right flow. We start with your global user base, the diverse reality of your employees or customers. As we move to the dataset audit, we see two diverging paths. The top path represents skewed data, where demographics, regions, or languages are missing. Feeding this into an AI results in a biased and irrelevant AI, which damages customer trust and brand reputation. The bottom path represents representative data, capturing diverse scenarios and languages. When this inclusive data powers the AI, the outcome is a fair and inclusive AI system that aligns with responsible AI principles. This visual clearly communicates that bias in AI is rarely malicious coding. It is almost always a failure to provide a representative dataset at the beginning of the pipeline. Understanding data types, quality, and representation leads us to action, establishing data readiness. What is data readiness? It is the holistic, operational process of preparing your data estate so AI can actually use it safely. The basics mean you must know exactly what data you have, where it lives, and how it is used. Why do we do this? Because deploying an advanced AI into a chaotic, unmapped data environment is a recipe for disaster and data leakage. How do you achieve readiness? It starts with data inventory and strict classification. You must ensure AI systems can access the right data sources securely and efficiently. For the deep dive, consider the technical enablers, metadata, and labeling. Tagging your data dramatically improves the AI's ability to discover relevant facts. Furthermore, true data readiness requires human feedback loops. You must enable your users to flag inaccurate AI outputs so the underlying data can be corrected and improved over time. This sequence diagram illustrates the lifecycle of data readiness in an enterprise. It begins with the data admin on the left, who first inventories and classifies the data estate, and then applies crucial metadata labels. Only after these two steps are complete does the AI system enter the picture. In step 3, the AI securely accesses the organized data. In step 4, it generates a high-quality output for the end user. But the process doesn't stop there. Look at step 5, the feedback loop. The end user flags any inaccuracies back to the data admin, who then updates the data estate. This creates a continuous improvement cycle. It visually reinforces that data readiness is not a one-time IT project. It is an ongoing operational workflow that guarantees long-term AI success. Once your data is ready, how does the AI actually use it? Through grounding and RAG. What is grounding? Grounding means explicitly connecting the AI's responses to your authoritative, verified data sources. The basics of this are handled by a technical architecture called Retrieval Augmented Generation, or RAG. Why is this absolutely vital? Because generative AI models are predictive text engines. They can easily produce convincing but entirely incorrect information hallucinations if they are not anchored to facts. How does RG work? It is a three-step process. First, when a user asks a question, the system retrieves grounding data from your internal files. Second, it augments the user's prompt with those facts. Third, it uses the language model to generate a response based only on that provided data. The deep dive here is a paradigm shift. RAG stops the AI from acting as a generic internet encyclopedia and forces it to act as a highly focused reasoning engine that only reads and summarizes your trusted enterprise data. Let's walk through the mechanics of Retrieval Augmented Generation, RG, using this diagram. On the far left, we have the user prompt. In a standard consumer AI, this prompt goes straight to the LLM. But in an enterprise RAG system, the prompt is intercepted and sent to retrieve internal data. The system searches your secure environment and finds trusted documents. Next, we augment the prompt, meaning we invisibly combine the user's question with paragraphs of your factual data. This massive, fact-filled package is finally sent to the LLM. Because the LLM is instructed to only use the provided text, it generates a grounded, factual response. This visual proves to business leaders how we eliminate AI fabrications by forcefully inserting your high-quality data between the user's question and the AI's answer. Slide 7 covers the protective shield around our data, security, and access controls. What does this entail? It means protecting sensitive information by ensuring the AI respects your organizational boundaries and compliance rules. As the basics dictate, strong security practices are the co-equal pillar of trustworthy AI, right next to high-quality data. Why must you focus here? Because if your security controls are weak, generative AI acts as a search engine on steroids, easily exposing sensitive HR or financial data to unauthorized employees, causing severe compliance and reputational damage. How do we prevent this? By strictly enforcing identity-based access controls. The deep dive reality is that tools like Microsoft Copilot are designed to be secure by default. Copilot pre-processes prompts through the Microsoft Graph. This means the AI strictly honors your existing file permissions. If an employee does not have permission to view a sensitive payroll Excel file in SharePoint, Copilot cannot and will not retrieve that data to answer their question. Security begins with your data permissions. This flowchart demystifies how data security operates within an AI environment like Microsoft Copilot. It starts when a user asks Copilot a question. Before any AI generation happens, the request hits the Microsoft Graph access check. This is the critical security gate. If the user lacks file permissions, the flow moves left, and the data is blocked from the AI. The AI cannot leak what it cannot see. If the user does have permission, the flow moves right, the data is retrieved, and the LLM processes it to formulate a secure and compliant answer. This diagram is your primary tool for reassuring security officers and stakeholders. Deploying generative AI does not bypass your security protocols. It actively inherits and enforces the exact permissions you have already established in your data estate. To synthesize everything, let's look at a highly important real-time use case, deploying a global HR copilot. Imagine your company wants an AI agent to answer employee questions about benefits, leave, and payroll. The basics are simple. You use RAG to ground the AI in your HR documents. But here is why data impact is everything. If a US employee asks about maternity leave, the answer is vastly different from a French employee asking the exact same question. If your dataset lacks representation, if you only uploaded the US handbook, the AI will give the French employee illegal or irrelevant advice. How do you succeed? You establish data readiness. You curate a high-quality, representative dataset that includes handbooks for every region, and you apply strict metadata tags labeling them by country. The deep dive result: when the French employee asks a question, the security access controls and metadata ensure the AI only retrieves the French HR data. The AI generates a legally compliant, localized, and highly accurate answer. This is how mastering data type, quality, and representation creates immense trust and drives real business value. Our final diagram maps out this successful global HR use case. On the left, a French employee submits a prompt about leave policies. The system routes this through a RAG architecture that applies a metadata filter knowing the user's location. This query hits our central database, labeled here as representative HR data. Because we ensured our data quality and diversity, the system successfully filters out the American policies and retrieves the specific French policy. This trusted data is sent to the LLM for processing, resulting in an accurate localized answer on the right. If the central database lacked representation or quality, this entire flow would collapse into compliance failure. This visual perfectly encapsulates our entire training. Robust, representative, and secure data is the ultimate engine behind scalable, high-value generative AI.